Welcome to the Smash series on the milking plant. I'm Noldy Rust, and today we're on the Sweeney farm with Dave Sweeney and Josh Wheeler from QCons. Today we're going to talk about cooling the milk and transferring it to the vat, how these parts of the milking plant work, and any troubleshooting issues.
So we've talked a bit about the cups and inflations, the mechanism of the pulsation.
Yep.
So once we get the milk down the milk line to this area here with the receiving can, Josh, do you want to maybe just talk us through the flow of milk and how it flows through?
That's good. Thanks for that. So if we look back up here, you can see that this is the milk line here. And you look, it goes right up to the other end there. So basically the milk line, once we lift milk up from the clusters, we're lifting milk up, it comes into the milk line, and then basically it drops to the bottom. And then we've basically got gravity bringing it down here. So we've got basically milk traveling along the bottom, and then we've got vacuum along the top. We have larger milk lines. We've been getting larger and larger milk lines. Typically this one here is 100 mil, but we would have looked back years ago and had 32 mil milk lines. Because of the milk flow, it was flooding and causing slugging. So the bigger milk line gives us more stability of vacuum, so the cow feels the same vacuum at every bale, basically. So milk's traveling down by gravity. So even in a rotary, when it's circular, the highest point will be the point away from the receiver can, and it will basically travel in gravity in both directions if it's a full loop line. So milk travels down in gravity, it comes down into here, and this is called the milk receiver can, okay? And this milk receiver can is where we separate liquid and air. So we're going to accumulate milk in the bottom of here, and basically the air is going to come through, and in this case here, this is a piggyback sanitary trap. This is the receiver air line, this little bit here. So the air is going out through here, into here, and out that direction, back to the vacuum pump. And basically the milk's accumulating in here, and then what we're going to do is then release the milk from under vacuum, and we use, you might call it your milk pump. Its technical name is a releaser milk pump. It will then suck, basically, it sucks the milk and then pumps it through the delivery line to the vat, and basically releases the milk from under vacuum and pumps it away. So the key sum up of this bit here, no matter how it looks in different situations, is you're always going to find a receiver can, and in the receiver can is where you're going to separate fluid and air. Either above or beside, you're going to find a sanitary trap. All new milking machines since about the early 90s have had to have a sanitary trap, and then from the sanitary trap you have a main air line heading back to your vacuum pump. And that pretty much sums up the milk side of it. The only variable will be you'll have different types of milk lift pumps. So this one here looks to me like a flexi impeller or a rotary lobe, one of those two. And then you'll have like a centrifugal milk pump, and you'll have a diaphragm milk pump. All got different, benefits, different things they're good at. Some are dearer, some are cheaper. So you see different varieties of milk lift pumps, all trying to achieve the same job, which is just separate milk from under vacuum and pump it away to the vat.
Just a question on that. Some of them are variable speed, is that right? Variable speed milk pump?
Yeah, so
is that important or not?
Yeah, so variable speed, I suppose the more expensive ones you buy that are variable speed will then have a slower pump out, so which means you might get a better cooling at your plate cooler. Some of them will just go full bang into full noise, and so you're pumping milk really quickly, so you get less benefit from your plate cooler in terms of cooling.
So what happens if that isn't working efficiently enough and we're getting milk filling up in the can?
Yeah, so what ends up happening if this isn't pumping, or for some reason this is sucking air, potentially we're going to fill this up with milk, and then the milk's going to flood up into the receiver, into the sanitary trap, and then it'll flood over and go over to the interceptor and then into the vacuum pump. So that's why it's always been important to have something where you can see what's going on in the milk receiver can, to see if it's going to flood, you can at least stop or change something and figure out what's wrong so you can pump milk away.
Yeah, Dave, my one fills up because our cow's got so much milk, but your one probably only just gets so high, does it?
No, none of those issues, no.
So when we left there out of the receiving can, we're sucking the milk out into a milk pump, and then the milk pump was pumping it through the delivery line. So this is the delivery line here coming down, and the first component we're going to run into is the milk filter. So we need to filter milk, make sure that any organic matter that we've harvested's been filtered out. We don't want to have to filter all the milk, so we should be harvesting it as clean as possible. So the plate cooler is basically where we're going to transfer heat from the milk to the water. So milk comes out of the cow at 36 degrees. It's travelling along this milk delivery line here. If from the milk delivery line it went into the vat at 36 degrees, it would take us hours to chill it. So we use the plate heat exchanger or plate cooler basically to transfer heat from the milk to the water. So milk's going to come in, it's a simple plate cooler, it's going to run up one side of the plate, and then it's going to come, this is a complex, it's going to run in, it's going to run up this half, then it's going to go through, drop down, and then come out this side, okay? And water's going to run the opposite direction. And if it's set up properly, we'll get within 2 to 3 degrees of the water. So if the water temp's at 10 degrees in spring, we'll get milk going in anywhere from 12 to 13 degrees if it's operating efficiently.
So if we're getting milk hitting our vat at 14 degrees,
yep,
we know we've got a slight problem back here somewhere to do with the milk not getting down the temperature.
So the first thing you've got to check is what is your water temperature, because it could be warmer than that, and so we haven't got the efficiency. The other thing we check, maybe we're pumping milk too quickly or we're not pumping water quick enough. And you normally look when the gap is 4, 5, 6, 7 degrees, because then you just lost the opportunity in terms of reducing that temp down and then reducing the pressure on the milk vat.
Yeah. Is it often a case of just chucking some more plates in there?
It can be the case of chucking some more plates in there, I suppose, if it's limited in size. Typically, the old system used to be, this is a commercial plate cooler, so it normally was 0.9 of a plate per cluster, so this is a 40-a-side herringbone. So 90% of that would be looking for about 34, 36, 37 plates. If you had the old small P30, you normally had 2 plates per cluster was the simple measurement. So if you had a 40 and you had those, you'd need 80 plates.
Yeah.
So that's a simple way of working out, but most of the time you might be pumping milk too quickly or pumping water too slowly is the key things.
Okay. Is it a simple process to actually pull that thing apart to see if it is working properly? Or what are the dangers of actually being...
Cutting your finger.
Yeah,
cutting your finger.
What's the dangers of being nosy with this bit of kit?
So the key thing to see if the water and milk's going fast enough or what's the difference is we basically, during the wash, when we have the milk lift pump on milk, we can just basically go to the end of the delivery line, have the wash water coming through, have a 20-litre bucket and see how long it takes to fill. If it fills that in 20 seconds, okay, then we know it's filling in 20 seconds. Then we go to the water side, turn the water on, and just see how long it takes to fill a 20-litre bucket. So if that fills in 10 seconds, we know then the water's running twice as fast as the milk, okay?
Right.
So it's quite simple to do. You don't have to open it. The only time you have to open it is if you think you've got a problem, something's blocking, something maybe a grading problem, then you open it up.
Yeah.
Wouldn't be that keen on opening the commercial plate cooler. They're pretty hard sometimes. Maybe the smaller ones are easy.
Should we head on out to the vat? Is that where we're going?
Yeah, so we'll follow the milk delivery line out to the vat. So we get out here, we've got the milk delivery line in this case coming along, coming down, and then basically it's going into the vat here. And we're delivering milk. We've got a tap here, so when this is up, the milk will be going in. It's in the down position now here, so it's closed. And so basically milk will go in, and we're delivering milk to the vat. In a sense, we'll try and fill the vat up to milk. So typically our vats are designed to take only about 60% of the milk in one hit. So if you've got 2 vats, then you're normally looking to spread that load and peak milk so you can get better and more effective chilling.